Volume maths can be used with a conditional nested formula to colour fill a stratigraphic sequence, as seen here in the section view. The formula is a simple if-then-else statement for horizons H1, the top reservoir, and H2, the base reservoir. The output is a constant value that is displayed as a transparent colour. For more information on constructing this formula, watch part 1 of this video series on sequence overlays. This video will demonstrate how to manipulate the components of the sequence overlay. The overlay sequence looks good in this section view, but if I zoom out laterally, the overlay develops a very obvious vertical artifact. The formula to create the overlay uses a conditional statement to compare the current two-way time to the top res horizon 1. If the horizon exists, then the statement works. But if the horizon is missing, then the statement fails, creating the artifact. The map view shows the problem clearly, in that the horizon has not been picked up to the edge of the dataset. Additional interpretation would be the best solution, but the horizon operation interpolate-extrapolate should provide a quick fix. Replacing the original horizon with the extrapolated one instantly fixes the artifact. I like the reservoir sequence highlight, but I now want to highlight all the sequences with a separate colour, and so the volume mass formula must be modified. There are 6 horizons in the section, so I must add another 4 horizons to the input and assign each one. As I change the definition of H1 and H2, the overlay sequence transfers to the top of the section. I can replace the final output NaN value with additional nested if-then-else statements. There is one statement per sequence, assigning the first sequence to NaN, then the second a value of 2, the third a value of 3, and so on, down to the 6th sequence, which is a value of 6. The bottom of the section is assigned value 7. There are 6 open brackets on the left of the equation, balanced with 6 closed brackets on the right of the equation. Each sequence is presented on its own row to make it easier to read and troubleshoot, but the formula can also be written as a single long row if preferred. Now this looks good, apart from that vertical artifact in the 3rd sequence. It appears to be caused by another horizon that terminates before the edge of the survey. Extrapolating the horizon is required to fill the sequence, but it will make no geological sense as the horizon truncates against the lower one. This situation requires 2 horizon operations to match the truncation to the lower horizon at 0 thickness. The first operation is a simple interpolate-extrapolate as before. Extrapolating the horizon fixes the vertical artifact because the horizon now exists across the survey. Unfortunately, it creates a new artifact, cutting down into the sequence below when it should truncate. The second operation requires horizon maths. As with volume maths, I have a quick help option if I'm unsure of the variables or equation used by Insight. In this case, I'm looking for operations to combine and merge horizons, specifically the minimum function. I select my 2 input horizons, then type the formula min h1, h2. This formula compares the 2 horizons at each location and outputs the minimum value from both. The result is a horizon that follows the lower one at 0 thickness. The volume maths process must be updated with the new horizon to see the results. There! The colour fill is fixed. Hiding the old horizon from the section completes the solution. The horizon exists across the survey, but at 0 thickness from the horizon below. Using basic volume maths, combined with some horizon operations, I've created a nice section view with sequence highlights for use in interpretation or presentation. Watch part 3 of the sequence overlays video to see how you can create a pattern fill for these sequences.
If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight.